Hello dear students, let's discuss embryology. Again, I am going to focus to the main important points, mainly targeting your entrance exams. What are the questions asked? We are going to learn all the points in and around it. Okay, so let's start with embryology of the eye. First important thing is when you say eye develops from, first important thing we have to learn is, if this is one exam question as well, eye develops from, you will answer it develops from forebrain, that is prosencephalon. Okay, prosencephalon. Okay, next important point, the development of eye starts at 22nd day of gestation. We'll say it is 22nd day of gestation. Okay, then we talk about next is another important point, which is the gene responsible for development of eye. We will learn PAX6 gene. Okay, so this is like a switch button where the eye starts forming due to this PAX6 gene. So any problem here will lead to what? We all know what is anophthalmia. Right, so any disorder, anophthalmia means the eye is not formed, or any disorder in the PAX6 gene can also lead to microphthalmia. We know what is microphthalmia, we have discussed in the lens chapter as well. It's a small eye of less than 21 millimeter of axial length. Okay? This is your microphthalmia. Or at 1 year of age, another criteria of less than 19 millimeters. At 1 year of age, if the axial length is less than 19 millimeters. Okay, let's see this slide. Once we know this, it is from the prosencephalon. What is the main process of formation of the eye? It starts with thickening of the neural plate. When this neural plate is thickened, next forms the optic sulcus. Correct? And later on, optic vesicle. Okay, so mainly this is the prosencephalon. I would like you all to make this diagram on your copy. How from the prosencephalon, these are the optic vesicles. Easy? Now, slowly it is going to form what? Optic stalk. So this is the optic stalk. So next diagram, first you draw this, second you draw this one. That this is what is optic stalk and this is your optic vesicle. Now optic stalk and optic vesicle, let's look here more, you'll understand better. This was the wall of the forebrain. Sorry, this one, right? And this is where the optic vesicles are being formed. What is outside is your surface ectoderm. What is the next story? This optic vesicle touches the part of surface ectoderm and this thickening of this part is what is called lens placode. What happens next? This lens placode and this is the optic vesicle slowly invaginates, forming the lens pit, right? And now see the optic vesicle is becoming optic cup. And this finally will lead to invagination from the surface ectoderm. This forms the lens vesicle from where the lens is formed. This is the reason, though lens is an internal structure, it is derived from surface ectoderm, and that is why it is so commonly asked question. Got it? Now, once we know this, we also know about the story of the lens, how the lens initially has both anterior and posterior epithelium, cuboidal cells. Slowly these posterior cells will form the columnar cells and change into lens fibers. Therefore, an adult lens has got only a single layer of anterior epithelial cells. Correct? Okay, let's further our story here. So you have made your prosencephalon and the optic vesicles. Done? What else? I hope you drew the optic stalk, optic vesicle, how it touches the surface ectoderm. There's an invagination here. You can draw this as well for yourself. And this forms the optic cup. So just draw these three diagrams. Right. What next? This optic stalk has got a gap. This gap is what is called choroidal fissure. and it is supposed to close. So these are the arrows showing you that it is supposed to close like this. And this is the next question. What is the ideal time of closure of choroidal fissure? It is 6th to 7th week of gestation. Okay, it closes by 6 to 7 week of gestation. Right? Now, any failure of closure of this choroidal fissure. Okay, so you can say 5 to 7 just to cover the variability, otherwise 6 to 7th week of gestation. Any defect in this closure, failure of closure leads to what? Colobomas. What are colobomas? Absence of that structure. Embryologically, that structure is not formed. What can be the different colobomas? First, this one, note down, lid coloboma. Right, as you can see here. Next, this is your iris coloboma. Right? This is your lens coloboma. Don't confuse with subluxation. This is your lens coloboma. So again, things will be asked in and around and you will be able to know what they are asking you. What else? Again, this one is iris coloboma. Same, lens. Right? Lens coloboma. This is your choroidal coloboma, this one. See? Here the choroid is not formed and the sclera is shining. This is your choroidal coloboma. This is normal optic disc that you are seeing, right? Okay, what next? So here the optic disc is not formed. This is your optic disc coloboma. Now one of a very specific optic disc coloboma. Okay, let me first cover this one. This is with both optic disc coloboma and retinochoroidal coloboma. Even this part is affected. Anyway, I was asking, one of the type of optic disc coloboma is what is called morning glory syndrome. There was exam question here. Write down, it's a dysplastic coloboma of the optic disc. What is happening here? It is happening due to either incomplete closure of choroidal fissure, which generally we know, or some mesenchymal changes. So this dysplastic coloboma, how does the disc look like is funnel shaped excavation of the disc. And what is important is look at the blood vessels, right? How do they look like? Like a spoke of wheel. And this resembles a flower which is called morning glory flower. Therefore, we call this as morning glory syndrome. Right? Or morning glory syndrome or dysplastic coloboma. And if you see, there is also peripapillary. There is atrophic change around the disc. Around the disc is the atrophic changes. Hence, peripapillary chorioretinal pigmentary and atrophic changes. Right? Okay. So, once we know about morning glory syndrome, we come to the next condition is what are you looking at now? This is, if you look at, these are myelinated nerve fibers. Now we need to learn a little bit here. Myelination of the optic nerve, it starts from lateral geniculate body and moves anteriorly till lamina cribosa. First of all, you remember this. So it has to stop at lamina cribosa. Any defect in the lamina cribosa will lead to this myelination coming anteriorly visible in the fundus like this. This is what is myelinated nerve fibers, and it is one of the cause of enlargement of blind spot. We have learned this. This will be a cause of enlargement of blind spot. Got it? Okay. Now this myelination, they haven't asked you the details when it starts and when it stops. But yes, have an idea, it will start in the 7th month of intrauterine life and it will just be completed after birth. Right? From 7th month till birth, it is completed. What is more important for you to understand? It should not come anteriorly, it should stop at lamina cribosa in the normal circumstance. Okay, let's see what we have next. So this is a condition which is, this is the condition which is called when the size of the disc is small, right? This is your optic nerve hypoplasia. And because of some peripapillary, if you look here, there are some peripapillary pigmented changes. We generally call it as double ring sign. The presence is generally said to be double ring sign. And if it is a small disc and that is leading to, due to the hypoplasia, do you also realize that this time the size of blind spot will be less? So this will be a smaller blind spot than the usual size. It will be a small blind spot. That would be the just opposite to what we just read in myelinated nerve fibers. Okay, and generally this optic nerve hypoplasia we can add here will be seen generally as a complication when we give steroids during pregnancy. Okay, yeah. Once we know this much, if this much of the story is clear to you, what next they will ask you in the exam is what are the structures derived from surface ectoderm, neuroectoderm, neural crest and mesoderm. So let's study and learn how to learn these different structures. First of all, give the heading surface ectoderm. I have just created a few interesting mnemonics for you all to retain this, but I really do not encourage too much of mnemonics because what is more important is to understand through your common sense first. So when you say surface ectoderm, it has to be some outside structures, right? So common sense, it has to be the epithelium of conjunctiva, cornea, lacrimal gland, and of course we just learned as an exception even lens because of invagination of the surface ectoderm into the optic vesicle, isn't it? So how to learn what are the structures? First of all, you should keep this in mind. So the mnemonic can be S, L, double L, double E, K. K is nothing, kuch nahi. S stands for skin of appendages. Eyelids, right? Eyelid skins, this is all surface and appendages. Make sense? Outside structures, surface ectoderm. Lens, of course, this is exam question as well. Make a Q here. Another L, lacrimal gland, again easy to learn. This is important, lens. Okay. After that, E, these are different epitheliums. So, epithelium of the cornea and epithelial lining of cornea and epithelial lining of conjunctiva. And K is nothing, kuch nahi, okay? Something like that. So, this is one way of learning what are the structures derived for surface ectoderm. I told you where the question has been asked. We next talk about is neuroectoderm. Okay. What are the structures derived from neuroectoderm? Again, before I am going to tell you the mnemonic and to learn, we will use our common sense. Neuroectoderm. Naturally, optic nerve, retina should be there. Right? So, let's learn it with an interesting mnemonic. Storm with an E. S-T-O-R-M-E. It's a storm with an E. Right? So, when you say S, this is secondary vitreous. I discussed this in the vitreous also, that secondary and tertiary vitreous, this is T for tertiary vitreous, these are all derived from neuroectoderm. O, of course, is optic nerve or optic disc, and with the optic stalk, optic nerve from the optic stalk, so it's all neuroectoderm, so we can say optic nerve. R is retina. Which muscles are derived from the neuroectoderm? We are talking about iris sphincter and dilator pupillae. These are the smooth muscles of iris. So, this is how they ask you. Smooth muscles of iris, we mean iris sphincter, dilator pupillae. And E, which epithelium? Epithelium lining of iris and ciliary body. Lining of iris and ciliary body. Okay. So, these are all derived from neuroectoderm. What are the questions? Why am I teaching you this? First question is, this one is Q, this one is Q, and these two are Q. First two and last two. Okay? Come to the next one. We talk about neural crest. Again, this is from the neural plate. You know? Derivative of ectoderm, neural crest. The neural crest has a neural part and a mesenchymal part. Neural part, generally the myelin sheath develops from this part, right? So, mainly, so when you say the neural part, this hasn't been asked to you, but we will just put it here. This is mainly the myelin sheath we are talking about. We all know myelin sheath is derived from oligodendrocytes when we talk about central nervous system and from Schwann cells in the peripheral nervous system. Okay, so myelin sheath, this is derived from here. We can also learn ciliary ganglion. We have talked so much about ciliary ganglion. Talking about the mesenchymal part of the neural crest. The mesenchymal part, we will learn here how to learn this? All coverings. Let us think of coverings. Outside, sclera. So first sclera, note down here, except temporal part. All the sclera except temporal part. Okay, what next? Choroid. Okay, we can note down choroid. What next? Cornea. What about cornea after sclera? So corneal stroma and corneal endothelium. Both are derived from neural crest. Corneal stroma, corneal endothelium. Okay. Then next we will learn ciliary muscles are derived from neural crest. Trabecular meshwork is derived from neural crest. Right? Stroma of not only choroid but iris and ciliary body. So stroma of both iris, ciliary body and choroid, they are derived from neural crest. Okay? And also the orbital bones. So these are the structures derived. Now what are the questions they have asked you? The first question has been on choroid, this corneal stroma, this is a Q. A separate question on corneal endothelium, this is a Q. And ciliary muscles is an exam question. These are the three questions from neural crest. What are we left with? Mesoderm. What are the structures derived from mesoderm? Let us learn with the mnemonic. We all know the subject PSM. We will put an E here. PSME. P stands for primary vitreous. We have learned this primary vitreous is hyaloid tissue derived from the mesoderm. S for sclera. Which part of the sclera, all of you? We are talking about sclera temporal part. The temporal part. Rest of the sclera is derived from neural crest. M. Which muscles? Extraocular muscles. And the endothelial lining of the blood vessels. These are all derived from neural. Mesoderm. Okay, we point out which are the questions. Primary vitreous has been the only question here, which has been asked in your exam. So put a Q there, all of you. Okay, right? So these are the structures, and this is how you're going to learn what is derived from what. Right? Be thorough with your Qs. So that's it in embryology. I don't think we need more than this. Thank you so much. Stay blessed. Keep smiling.